For a long time now, I have been a huge fan of Minecraft. Its terrain generation, which was absolutely mind blowing to me at first. The fact that you can generate a world again and again, and every time it's completely random, it just blew my mind. So, for the past month, I've been working on this project, and I thought, why not incorporate the Minecraft terrain generation? Not to that scale, but I did incorporate it in one dimension, which uses one-dimensional Perlin noise to generate the terrain. And I use three layers instead of just one to make it more cohesive and also make the layering very, very smooth. So this game incorporates elements from classic games like Mario, those very popular platformers, and also from Minecraft and mainly Terraria, which is also a two-dimensional game and used one-dimensional noise. So now for the demo of the game and also to show you the code. Enjoy. So first, as you can see, the terrain is generated as soon as the player spawns in the game. This terrain is created using one-dimensional Perlin noise, which ensures that every time you play the game is unique. The terrain is also divided into chunks so that as the player moves forward and through the chunks, the noise takes care of the generation of the terrain. These chunks help ensure that the game runs smoothly and there are no lags. So this game runs at 60 FPS and it's currently an 800 by 600 game. So now let's start by moving my player. So as you can see, this is 60 FPS with the clouds being a sort of parallax effect. The jumping mechanic is very intuitive, with the spacebar being the obvious choice, with left and right being dictated by the A and D keys respectively. There's also a dash mechanism which allows me to also eliminate players, and this is one of the more strategic parts of the game because there's also a cooldown period on the dash, and it only eliminates at max two enemies at once, so you can't kill like a whole mob of them. Now, the enemies are generated infinitely and randomly based on how many enemies I have eliminated before. So if I eliminate these two, then there will be more here, ensuring that there is increasing amount of difficulty in the game. There's also a line of sight AI which allows the enemy to detect where I'm there and then it shoots. And if I die, it goes to a screen where I can either press R to restart or I can quit the game to exit. So let's restart, and we're again in a brand new, newly generated terrain. And so let's interact with an enemy. So let's say I jump in front of the enemy. It shoots once, as you can see, my health went down, and then there's it shoots again, and then there's a period of cooldown for 2 seconds, as you can see, and then I die when my health goes below one. So as you can see, my score increments based on the distance I have traveled, and also if I eliminate an enemy, the score increases again with a jump of 20 points. So the larger score you get, the better you are playing. So the scoring system helps me to keep track of how good I'm playing and how many enemies will therefore spawn. So yeah, that's basically the gist of the game. And now let's move on to the code. So this is the main game code which runs Pygame, and this is the main game class with every import imaginable on top. This stores all the assets which are like the player run animation or the player jump animation, and this is basically a dictionary making memory management and obtaining the actual values very easy. So this function, which is called over here, generates a set number of enemies anywhere on a random position from 50 to 500x and 50 to 300y. This generates a random number of enemies anywhere from 2 to 7, and that is also the player position plus a random number from 200 to 400 as we want the enemy to spawn outside of the player's screen or outside of the camera what the user is looking at. This updates the score depending on the distance traveled by the player and also if the player has eliminated an enemy. And this renders the score on the screen, this renders the health on the screen. This is the game over screen with the sorry you lost and this message showing. And this is an infinite loop which checks for whether you have quit Pygame. And yeah, if you have, it exits the system and quits Pygame. This is the run function, which basically runs the game. So this is while true as running is equal to true. And self.display.grid basically is showing you the display. And these three lines here are basically your camera, where if the player moves, your camera and your view of the player moves along with you. This renders the tile map. This updates the player with any movement you have made or done a dash or anything. And this again renders the player after the update, so you can actually see it on your screen. And this gigantic block of code is what handles the bullet that the enemy actually shoots so that you can take damage. And yeah, so even I have trouble understanding it sometimes, but the basic thing is this updates the X value of the projectile, making sure that it doesn't go up and it travels in a straight line. And all of the if, elif, elif, if statements here check whether there is any block in between the enemy and the player, so you know the projectile doesn't hit the player. And this code is responsible for checking what key you have pressed. So if it's C, then it dashes. If it's a spacebar, it jumps. And if it's either A or D, it moves left and right. This code makes sure that it confirms when you actually quit the game. So yeah, if self.confirm quit, then you ask this, and if they are sure, then yeah, the game quits. And self.clock.tick is responsible for your 60 FPS, which is set to 60. So this is the tilemap.py file responsible for actually generating the terrain. Uh, this is basically what the game uses to check what kind of block should come next to a particular block. So like if a grass block is there, then this makes sure that besides the grass block, a stone block is generated instead of a cloud or something. Um, And this is the main selling point of the code, which is this generates each chunk based on the noise. And this code generates three different layers of one-dimensional noise, which are stacked on top of each other to make sure that the terrain is smooth and also very cohesive. This block of code makes sure that the tile generation is properly optimized by making sure that tiles are only generated where the player is currently. So if a player is at position X, then it only generates the tiles at X and also at X plus 1 and 2, and not anywhere after or before that. So this makes sure that it only generates the tiles where your camera is, and not anywhere outside of the screen. This is the main render function which we use to actually show the tiles on the actual screen, and this just checks whether a block is solid or not. This file contains our entities, which there's a basic layout for an entity, which is called a physics entity, and yeah, there's a gigantic block of code called update, and this is basically used for updating the player's animation along with checking for collisions and stuff. And this shows the actual entity on screen. So this is the enemy class, which inherits from the physics entity, so I don't actually have to write all this code again. And some stuff is different, like the update function. So that is different for the enemy and as well as the player, as the enemy has to check its line of sight for the player. This part of code is responsible for checking whether the player is inside the line of sight of the enemy, and if the player is, then the enemy shoots the projectile. In this case, it's the bullet. These two are responsible for the animations for the enemy, which are much less comprehensive than the player, as this just checks if the enemy is moving, then run animation, and if the enemy isn't, then idle animation. This code checks for the player colliding with the enemy while dashing. So if the player is dashing and the player collides with the enemy is eliminated. This is the main player class, which again inherits from the physics entity and has its own update function. This makes sure that the player can only jump one time and there are no double jumps. And this code makes sure that the player can wall slide and wall jump. This checks whether, like, if the player is not wall sliding, then if the airtime is greater than 4, then the action is jump. If the player is moving in any way, then it's run, or if none of these are true, then the player is in idle position.
This part of the code is responsible for the animation part of the things, which the basic gist of it is that this handles the particles where the player disappears and there's a black particle effect. This part of the code makes sure that the player doesn't go infinitely to the right while dashing. So if the player dashes, then if this part of the code wasn't there, the player would just keep on going until it collides with uh, any entity, or if the player is killed by an enemy or collides with a tile map. This checks whether the player collided with an enemy as well. For the player point of view, which adds the enemy score to the player's total score. This renders the player, and this checks whether the player is jumping. And if the player is jumping, then it first checks whether it's a wall slide jump, which has a different animation than just a regular jump.